Hello, everyone, and welcome to our webinar, How to Launch ChatGPT LLM Apps in 3 Easy Steps. My name is Matt Brown, and I'll be your moderator today. Before we begin, just a few logistical reminders. Today's discussion is being recorded, and you're currently in a listen-only mode. You can submit questions throughout the session using the Q&A functionality in the lower section of your Zoom console. This is your first time joining a SingleStore webinar. Heads up that we present regular webinars demoing data and AI use cases and new technologies. In fact, if you like this topic, you'll be very excited to hear that tomorrow we will be presenting, and if you click to the next slide, you'll see Google Gemini Preview and hands-on with Vertex AI. Unless you've been living under a rock this week, you might have seen some of the online clips of Gemini in action. Talking and reasoning in real time, identifying a blue duck, inventing a geography game, handling math, etc. Very cool stuff. Gemini models will be released for developers to integrate into their applications on December 13th. So now is the time to learn about its capabilities and learn about Google AI Studio and Vertex AI. So if this sounds interesting to you, feel free to register right now for that webinar tomorrow. You see the bit.ly link, Gemini Preview and Vertex AI Demo. I'll put that link in the chat in a few minutes. And you can also take a photo or a screenshot of that QR code, which will take you to the same place. And I hope to see you there tomorrow. So back to today's topic, we have some fantastic technical experts who will be on our Zoom Q&A, who have a grasp of the technologies. We'll answer as many of these questions as they come in. We will also follow up with email for anybody that we don't get to. And I'll also flag a few for the live Q&A at the end of today's session. If you click to the next slide, you'll see that we would love for you to try out what we're going to be showcasing today. In fact, anyone who tries it today will be entered for a chance to win the new version of the latest Apple AirPods Pros. All you need to do is click the link or visit that link that's on your screen, bit.ly ChatGPT 3 Easy Steps raffle. You can also scan the QR code that's on your screen, and I'll put that link in the chat in a few minutes. And it's very easy. We have a free trial if you're a new user, or you can log into an existing account if you are already a customer or have an ongoing trial with SingleStore. So all you need to do is log in. We will check those folks who log in today, right now, and we'll announce the winner by the end of today's session. So stay tuned to see who wins those AirPods. Let me introduce our speaker for today. Ayush Pai is a computer science student at Georgia Tech. He's got great expertise in big data, machine learning, AI. We've partnered with him on a lot of webinars now. He's getting to be an old pro. Welcome, Ayush. And then my name is Matt Brown. I'm the head of global growth at SingleStore DB. I have the pleasure of organizing these weekly webinars on AI that show the world what's possible with AI when you have a general purpose database with vector capabilities. So very fun job. I love this. And yeah, I'll be giving a quick introduction today before we get over to Ayush. So quickly want to go through what is SingleStore DB? Why do we do webinars like this? Why are we the perfect solution for fast AI? Well, quickly, SingleStore is a distributed relational database system that can handle both transactional and analytical workloads in the same engine. Years ago, this was great for high power and data intensive applications that critically needed both scale and speed. The example we like to use internally is the Uber app. Uber is a customer of SingleStore, so you can imagine, when you open your Uber app, there's lots of things going on. There's hundreds or thousands of drivers online in your region. They're being tracked from a geospatial standpoint. Hundreds of thousands of riders querying the database, looking for a ride, wondering what their fare will be, wondering when their driver ETA will be. And so that moment is very important. If there's any sort of lag or delay in that user experience, then the riders will just abandon the app and pop over to a competitor like Lyft. So that application critically needs both scale and speed. The entire business depends on it. So that's where SingleStore steps in. But then back in 2017, something else happened. SingleStore has a lot of financial services customers. We're not allowed to mention all of their names, but you can think major banks, top 5, top 10 in the world. Speed and scale are very important to them. And one of them in particular, I can't mention its name, it pushed SingleStore or MemSQL, as we were known at the time, to develop vector capabilities. We did, and we further honed and developed that capability over the years. And then suddenly the AI boom has now arrived, which is awesome for SingleStore. So now you click to the next slide. We've got distributed MySQL compatible architecture that can handle streaming, data ingestion, analytics, and transactions in the same engine. Multi-model capabilities, so you can think JSON, time series, full text, spatial and vector data. So if you like MongoDB's simplicity of handling JSON documents, but you don't like its speed or performance with real-time analytics, SingleStore has a Mongo API for that. It's called Mongo Kai. If you like the power and data of a data warehouse like Snowflake to handle large-scaled BI analytics, but you don't like Snowflake prices or speeds, then SingleStore has you covered for that too. You like MySQL's familiar SQL syntax, you like those costs of MySQL free, but you don't like MySQL's laggy performance at scale, then SingleStore is a great option for you. And then finally, if you like Pinecone's focus on vector indexing and similarity search for Gen AI apps, but you don't like the idea of adding another specialized database for a specialized use cases, you want the speed and scale, you want the multi-model support, you want SQL, then SingleStore DB is a great option. So architecturally, you can see all of that in this slide. You can also see some awesome, integrations and connections we have. You can see up there, I think there's the logos for Kafka, so streaming data. There's Spark up there. There's Hadoop. And then at the bottom, you'll see that SingleStore plays really well on all three major cloud platforms, AWS, GCP, Azure. You can run it on-prem as well. And there's a Docker container as well. So that's kind of a nice low risk way of trying it out. So I think that's about it for the intro to SingleStore and why we are here. Let me hand it over to Ayush now.
Awesome. Thank you, Matt, for that great introduction. And let's get started. So before we jump into the whole webinar, let's do like a quick introduction to the history of AI. So let me introduce myself first. I'm currently studying computer science at Georgia Tech. And today we'll really be taking a brief, fascinating journey through the history of AI, which really sets the stage for LLMs and all the applications that we'll be discussing today. So AI has really come a long way from its theoretical foundations in the mid-20th century, through the rise of machine learning in the late 20th century to deep learning breakthroughs in 21st century. And most recently, we've seen the rise of advanced architectures and the advent of the transformer models that have really revolutionized the field as we know it. As we explore this rich history, we'll really be able to gain a deeper appreciation for the capabilities of the ChatGPT LLM and how it can be integrated to some really modern applications here. So just as some early AI foundations, back in the 1950s to 1960s, we really witnessed the birth of AI as a formal academic discipline. It was a time of great enthusiasm and pioneering spirit, which really marked a really early focus on AI and rule-based systems, which are really programs that operated and encoded on rules of logic. And concurrently, we really saw the development of basic neural networks and something called a perceptron, which was actually inspired by biological brains. And one of the most notable figures during this time was Frank Rosenblatt, and he created the perceptron, which really laid the groundwork for future explorations into both single layer and multi-layer neural networks that we'll discuss more in depth shortly. But you can see this diagram here. It was kind of like the first diagram of a perceptron, and Frank Rosenblatt, who kind of pioneered that first version and really led the way in kind of these neural networks that we're actually implementing in the 21st century now. So as we progressed really into the 1980s, 1990s, there was kind of a paradigm shift in AI from rule-based systems to learning-based systems, which really marked the rise of machine learning. And this era was really characterized by the development of algorithms that could learn from data, such as decision trees, support vector machines, SVMs, pretty popular today, ensemble methods that really combine multiple models, which we're kind of seeing today as well, for improved predictions. And a significant breakthrough of this period was really the resurgence of neural networks. I think in the decade previous to this, it kind of faded away. But in this decade, we had the backpropagation algorithm that came out, and which really allowed networks to adjust their weights and improve their performance. And the big problem with neural networks was there was a lot of error after going through the layers, and this allowed the neural networks to actually take their weights, improve their performance based on a loss function. And this was a really pivotal moment that really sets the stage for the learning revolution in the 21st century. And so these are kind of the models that we saw: SVMs, ensemble methods, decision trees that really defined it. And here's just an example of a stacking ensemble, which really uses input and then multiple models to create a decision. And so that really set the stage for the deep learning era, which spanned from 2000s to 2010s. And it was really a period of significant breakthroughs, which really ignited an explosion in neural network research. The availability of extensive computational resources and vast data sets, notably ImageNet, which released in 2009, were really critical catalysts. ImageNet really provided a large-scale data set of annotated images that became a benchmark for training and evaluating deep learning models. And ImageNet is still widely used. It's really popular. And this period was really defined by innovations such as CNNs, which are convolutional neural networks for image recognition, which were really instrumental tools and models that surpassed human level performance in image classification tasks, such as classification and even segmentation in a little bit. And recurrent neural networks is another pretty big innovation in this time period. And this really made strides in sequence modeling, enhancing the performance of models in language processing and other sequential data applications. And sequences are really important, as you can see, and we'll see it as we explore some other model architectures. But this era really was epitomized by events like the IBM's Deep Blue victory over Grandmaster Kasparov in 1997, which really highlighted the potential of machine intelligence. And this was a really key moment in AI where the best chess player in the world actually lost to an AI machine. So, and in the 2010s, we had the CNN and RNN, which are the prime innovations there. So in the mid 2010s, we really witnessed the rise of really advanced architectures that we kind of see all throughout today. And these really push the boundaries of what AI could achieve. So long short-term memory units are models called LSTMs, and gated neural recurrent units, GRUs, really define the art of sequence modeling, offering our systems a memory of past inputs. And it's critical for tasks like language translation, speech recognition. Equally transformative were attention mechanisms, which allowed models to focus on relevant parts of input data, which were really vastly improving performance in natural language processing. A significant leap in video interpolation came with temporal shift modules, TSM, and these really enable networks to efficiently understand and predict actions in videos. Previously, videos were being analyzed with LSTMs, with a combination with a CNN or something like that, where they were really taking in one frame at a time and trying to analyze from that. But this really gave them an ability to kind of actually determine with some processing such as optical flow and advanced processing like that allowed temporal shift modules to really take a place and predict actions in videos. And these impact advancements are really made manifest in milestones that, for example, in 2016, we had Lee Sedol and AlphaGo, and that was a pretty significant event in AI, where AlphaGo's victory was not just a win for the game of Go, but it was really a demonstration of how far neural network architectures have advanced in 2016 and combined with strategic thinking and intuition in ways previously thought to be exclusive to human intelligence. So that was a key moment in AI. So in 2017, there was a really groundbreaking paper that was released called Attention is All You Need. And it really introduced the transformer model, marking a revolutionary shift in the world of AI and NLP. This model really pivoted away from previously dominant RNNs, CNNs for sequence processing tasks, and towards a more architecture based entirely on attention mechanisms. And these mechanisms allowed models to weigh the importance of different parts of input data, leading to significant improvements in efficiency and effectiveness. And transformers quickly set the new benchmarks across a ton of NLP tasks. They could handle long-range dependencies in text that was really greatly acute, leading to better understanding and generalization of natural language. And this was really made possible due to the model's unique structure, consisting of an encoder to process the input text and a decoder to generate the output. And this encoder-decoder model is a pretty popular style of models and architectures to this day. And inside the multi-head attention layers, they're enabled the model to focus on different parts of the text simultaneously. And it's a really key part to its versatility and power. The success of the transformer model has really been unprecedented, and it enabled breakthroughs in translation, summarization, question answering, and more. And it's really laying the foundation for much of NLP, and including the very large language models that we're going to be talking about today, such as ChatGPT and all these other models. And we really continue to refine and expand upon this architecture, but it's really the base for a lot of these LLMs that we see in our modern applications. So since 2018, the development of large language models or large-scale transformer models has really spearheaded a new growth in AI, a new era in AI, as I mean. And that's really the era of large language models, as you've seen. These models, including the generative pre-trained transformer, GPT, as you all know, BERT, which is the bidirectional encoder representations for transformers, and others, have really revolutionized their approach in natural language processing. GPT-1 was released in June 2018 by OpenAI, and it was really a pioneer, really leveraging unsupervised learning to predict the next words in the sentence, and it followed by GPT-2, February 19th, 2019, which was larger, more capable, and it generated more coherent and contextually relevant text over long passages. OpenAI initially limited GPT-2's release date due to concerns about misuse, but obviously they had much better, much bigger models after that, considering that they thought that was so powerful back then. Then came GPT-3 in May 2020, which was completely shattering what was state of the art at the time, with 175 billion parameters. And it really demonstrated an unprecedented ability to generate human-like text, solving tasks with task-specific training. GPT's ability in translation, question answering, and summarization really pushed the boundaries of AI, and it got a really high score in a lot of the AI benchmarks that we use today. And building on this lineage, we have the subsequent evolution of models like ChatGPT, which arrived in 2022. At the end of 2022, we have offering really more nuanced and sophisticated interactions. And these models were when ChatGPT was released with GPT 3.5, and had, I think, around, I'm not sure of the number, I have it later in the slides, but the parameters was a lot more than GPT-3. And the deep contextual understanding, the enabling of a wide range of applications, and nuanced dialogue. There's so many more advanced capabilities of GPT 3.5 that we saw. And today we stand with GPT-4. And this latest iteration, which continues to expand on the frontier of what's possible in AI, it's much better than its previous iteration, GPT 3.5. And we're seeing this over and over as we see more and more models released. As we saw yesterday, we had Gemini, which is supposedly even better in terms of some benchmarks than GPT-4. So this is really the era of large language models, and we're seeing, since 2018, we've been seeing some of these been rapidly, exponentially increasing in terms of performance and accuracy, etc. So ChatGPT, just an overview of the LLM. So ChatGPT represents an cutting-edge AI technology, which is a sophisticated model constructed upon the transformer architecture that's really been pivotal in advancing natural language processing. ChatGPT excels in understanding and generating text that is really indistinguishable from written human. And in a lot of cases. And there have been attempts for GPT-0 and even OpenAI to actually try to interpret if it's AI generated or tech or human generated, but a lot of these accuracy scores for those classifiers are very low. So it's definitely very, very difficult to distinguish from a human. And it really enables a wide array of applications that the range of controversial agents to complex problem-solving tools. It's really unlimited what the applications you can get from this. And the model stands out for its ability to learn and adapt, ingest a vast corpus of text data, fine-tuning its algorithms to deliver responses with a remarkable accuracy and nuanced understanding of context. The proficiency of ChatGPT in tasks like conversation, text completion, summarization, translation really demonstrates its versatility. And not only does it understand and generate text, but also can do so with variations and intricacies of human language, with slang, etc. Because it's a large training data set, which we'll talk about in a little bit. So with the advent of GPT-4, we really seen an evolution towards multimodal language or capabilities. And GPT-4 Vision, for instance, was released a couple months ago, really extends these linguistic abilities into the visual domain, really allowing the model to process and understand images, opening up new avenues for AI applications that could really interpret and generate multimedia content. And I think the shift from GPT-4 onwards is really going to be multimodal abilities. As we saw yesterday with the Gemini release, and make sure to come to tomorrow's webinar, which we'll go a little bit more in detail with. But Gemini's whole model is kind of centered around the multimodal aspect of large language models, and that's their whole goal, right? And GPT-4 Vision does a pretty good job, but I think the image benchmark, image classification benchmarks that we saw from Gemini are a lot better. And these implications of ChatGPT's capabilities are really profound, not just for the field of AI, but for industries worldwide. And it really offers tools that can transform data into something more meaningful, actionable insights, and create interactive experiences that were once fiction in a lot of cases. So let's get into a step-by-step guide of really integrating LLMs into your applications. So that's what this whole webinar is going to be about. So there are three main steps we really have, three simple steps in concept, but implementation will go over a little bit the more fine details of how it's going to work. So the first step is the API integration environment setup. We're going to be working with Python in this one. So the next step is data preparation and model customization. And for model customization, you can either do RAG versus fine tuning, and we'll go over all of that. And the final step is deployment and scaling into your applications, and we'll go over that as well. So let's start off with the API integration environment setup. So the first step in really leveraging these large language models for your applications is the API integration environment setup. So select the appropriate LLM service, such as OpenAI's GPT. There's a lot of open source large language models you could use as well. But OpenAI, currently, the API is the most state-of-the-art model you can use. And you can get a secure API access from OpenAI's website, create an account, etc. With the key in hand, you can really prepare your development environment, and this involves installing necessary libraries and tools. You need to do an HTTP request potentially for libraries or pip install based on what you're doing to communicate with the API. And then also AI platform and SDKs that are specific to your chosen LLM needs to be installed as well. So once your environment is configured, the next step is really implementation and integrating the API calls directly within your application's code base. So carefully crafting each request, pip install, requirements.txt, etc., ensuring your handling of your responses are robust. And this is really a meticulous process, and you want to make sure, based on what your code base is, you're able to get some seamless integration there. And finally, you want to pay close attention to error handling, authentication, and efficient management of API rate limits. So the goal is to really minimize API calls The thing about the OpenAI API right now is it's pretty expensive. And there are free alternatives if you go with Llama, for example, from Meta, and some other free large language models pre-trained that you can actually fine tune as well. But OpenAI definitely has the most parameters and is definitely the most state of the art right now. So it is going to give you a cost, and the whole goal is to reduce that cost. And we'll talk about how we can do that. So so that's the goal, to reduce those API costs, create a really fluid, stable, and responsive integration that really harnesses the full potential of LLMs, such as ChatGPT, and GPT-4, et cetera, and transforming your application into something really intelligent. So here is OpenAI's website, just an overview. And this is where you can actually set up your API keys. I have a few of them here, for example, and you can see when they're used, and create a new key. And this key is really what connects your API to your actual app. So you would actually take this API key, you would put it into your environmentals, and I'll go on that in the next slide. And you would actually be able to use your connect directly to here. And this is where you would pay any API of fees or et cetera. And you can see the usage in the left corner as well. So API integration. So this is where you actually are going to be integrating the API key directly into your app. So we're going to just do this example in Python, but I'm sure they have other applications as well. So building on our previous discussion, let's really dive into setting up the environment. So let's focus on Mac first, Mac OS. So begin with the OpenAI library installation. You can do pip command, pip install OpenAI, or you can upgrade it based on the version you're at. So then what we're going to do is we're going to access terminal, and we're going to access the bash profile in the nano editor. So if you can follow through these steps here, and I won't go too into detail. This is all in the documentation as well. And here you'll really add your environmental variable, which will contain your API key and secure your convenient access to your applications. You can add your API key to every single program you want to do, but that's very tedious, and it's also not good practice. So it's best to add it directly to your environment so that your API key doesn't get leaked, or when you push it to GitHub, for example, you don't want it there as well. So save the changes and source your profile to activate the setup, and always verify by doing like an echo to the API key in the terminal, and it should display if your key is done correctly. And for Windows users, the process really mirrors these steps in the command prompt. So set up your environmental variable, and continue those steps there. And I won't go too much in detail for this. Okay, so upon the successful environmental setup, you're really ready to integrate into the OpenAI API directly with your Python application. And the basic implementation is really illustrated in the code snippet below. So the OpenAI Python client is initialized, which really allows for creating chat completions. And chat completions is what we're looking for here, which is like kind of the Q&A style questions. And in this example, we utilize GPT 3.5 Turbo model for its efficiency and capability. You can also use GPT-4, GPT-4 Vision, etc. Whichever model you want to use, you would put that in the model variable. And the code demonstrates customization for really defining roles. So I'll be talking about what these roles mean and how they can actually customize your responses. So three main roles are system, assistant, and user. And so this particular set like allows you to request a poem, a recursion, about recursion, for example, in this one, and really showcases the flexibility of the API. So the system is kind of like you're telling the model like what it's supposed to be. It's like the overlying system. So in this example, it's you are an all-knowing computer science professor. So it's kind of setting the context for the model. And then the user is what their message to the model is. It's saying compose a poem that explains the concept of recursion in programming. And some models also support multimodal inputs, such as GPT-4 Vision. Really enables interaction between text and images. And you can also, in the user content field, right here, we can actually input images there as well. And I'll show an example of that later on. So just a key OpenAI LLM models overview. Since we have the option of changing which model we want to use, it's really important to understand the differences. And these are the official names of the models that you would be actually interacting with. So as we really want to look at these, so the GPT-4 1106 preview is also known as the GPT-4 Turbo, and it stands as the most powerful model right now that OpenAI has to offer in terms of large language models, and it has a 128,000 token context window, which is great. It kind of just expanded to that in like the last few months, and it's trained on data up to April 2023. So it's pretty updated in terms of what it knows and its abilities. And so although it outputs a staggering 4,096 tokens, which is really, really good in terms of how, and that the tokens is actually like can be converted to words. And they have a conversion on the website based on how many tokens equals words, but tokens are like how much it can output and input. And 128,000 token is really good. I was thinking, I think on stage on OpenAI actually mentioned it could take some text, some small size textbooks as well. Some really big amount of context that you can put into your input, which is great. So the GPT-4 Vision Preview is a variant of the Turbo, and it really integrates vision and allows it to understand images alongside text, presenting a multimodal approach. And it shares the same context window and training data timeline as the counterpart. The GPT-4 represents the base model of this generation. And it really, the context window is reduced down to 8,000 tokens, which is a lot less. And it's been trained up to data on September 2021. So it's a little bit more outdated as well. But it kind of serves as a more robust balance, and it's actually production ready. And lastly, we have GPT 3.5 Turbo, which is what ChatGPT was powered for a long time. And GPT 3.5 Turbo really provides the same output token as the GPT-4 Turbo, same output tokens, 4,096. But the input context window is a little bit smaller as well, 16,000, bigger than the base GPT model, but less than the turbo of GPT-4. And this model is really ideal for applications requiring high performance, slightly narrow focus, but with still pretty good performance overall. And obviously, it's trained up to only September 2021. And I'll talk about why in the next slide. It actually takes a lot for them to train these models and make them more updated. But each model serves as different needs, kind of high performance computing applications to visual data processing, etc. So comparing GPT 3.5 and GPT-4, we really observe distinct advancements in scale and complexity. So the parameters, which is the elements of the model's neural network that are trained and are learned from training data, really shows a significant jump from 175 billion in GPT 3.5 to 1.5 trillion in GPT-4. And this increase really allows GPT-4 to capture more of more subtle nuances and languages and context. And the training cost really reflects the financial investment from OpenAI required to train each model, with GPT 3.5 at 4.6 million, GPT-4 at 63 million, and really indicates the latter's more expensive and complex training process. Training data represents how much data that was the model was trained on, and 17 gigabytes for 3.5, 45 for GPT-4. And you can see a lot, all these statistics are a lot higher for GPT-4. And 1.5 trillion parameters is crazy. And this MMLU benchmark represents the model's performance, which stands for Massive Multitask Language Understanding Benchmark, which is really a suite of tasks designed to measure language understanding. GPT 3.5 has scored 86.4%, which suggests that while GPT-4 has more capacity, its performance on specific tasks can vary compared to its predecessor, emphasizing trade-offs. So, or actually, sorry about this. These numbers should be switched in this table. GPT-4 is actually 86.4, and GPT 3.5 is at 70%. So sorry about that. But actually, something that's kind of crazy is Google Gemini came out yesterday, and it had MMLU benchmark score of 90%. And that's much higher. That's 4%, almost 4% higher than GPT-4. And it shows how these are really these models are evolving over time. And I'm pretty sure the actual Gemini model, the most advanced Gemini model that came out, had over 4 times the number of parameters as GPT-4. So you can see as we increase the number of parameters, increase the amount of training data that we're putting into these models, you get better performance. And sorry about the number switch up here. It should be 86.4% for GPT-4. Okay, so benchmarks. Here's the correct numbers. So for MMLU, just overall overview of what these benchmarks mean. So MMLU really assesses the model's grasp of multiple choice questions and diverse subjects, showing the GPT-4's really superior performance here, over 16%, which is kind of crazy performance that the GPT-4 had, but it's kind of understandable based on how much more training data, how much more parameters really went into it. HelloSwag really tests common sense reasoning in everyday scenarios. GPT-4 again leading there. And here's just a couple more benchmarks. And I can explain some more of these if you have questions at the end, but we can move on to the next slide. So in the realm of OpenAI LLMs, so we'll talk about roles. Specifically, there are 3 roles. So the system, assistant, and user role. The system role is really designed to guide the conversation, as I was showing before, but like the computer science professor role. And so you can really guide the conversation by setting the context or providing instructions. And the assistant role is fulfilled by the AI itself. So the assistant is the AI model that you're actually communicating with and crafting responses based on the system's cues and the user's input. And lastly, the user role represents the human interacting with the model, whose inputs really prompt the assistant to generate replies. And the code snippet below really illustrates these roles in action, the conversational setup, and understanding and utilizing these roles effectively is really key to creating a dynamic and engaging interactions with this model. So the system role really serves as a foundational element in orchestrating the behavior of your large language model. It's kind of the director behind the scenes, setting the stage of how the system should interact with the conversation. So you can define the system's message. You're essentially programming the personality and operational guidelines of the AI. For instance, if you inform the system that the assistant is a supportive and informative guide, the AI will adopt a tone and really respond in a pattern that aligns with this character. Its tool is really for customizing the user's experience, ensuring that the AI's demeanor really outputs and the outputs are congruent with the desired interaction style. So if you're trying to go for more of a customer support style, you can actually set that kind of tone there. If you're going for more of a playful style, etc., you can do that as well. It's really important to recognize, though, that the system's message isn't mandatory. So you can leave it blank. You don't have to actually fill in this parameter. So without the assistant really defaults to a generic interaction model. And this can really resemble just like a neutral, helpful assistant. And it's kind of like the same as just setting the system's message to you're a helpful assistant. And so that's just an overview of the system role. Next, we have the assistant role, and this really embodies the LLM's voice, providing responses to the user's prompts. It's a really crucial component that really retains the context of the conversation, utilizing past exchanges and inform current responses. So this really ensures the continuity and relevance of the conversation. So by retaining the history of its responses, the assistant really maintains the conversational thread by building previous interactions to create a coherent and engaging dialogue. This is essential for complex interactions where you have to require understanding of both the discussion's progression and the user's tone. And you, as a developer, can really shape the assistant's behavior by setting examples with the system's role messages. So, for example, you can really prompt the assistant with specific tone or directive that can induce a particular response or style that can be shown in the example below. And this customization really allows the assistant to act as kind of like a kind of like a person who's kind of like a mediator, really adapting to prescribed roles and really enhancing the user experience and versatility. And this slide, this code really shows the assistant in action, responding to the user queries with informed answers, and it shows how without this context from the assistant, it would not be able to answer this next question, where is it played, because the assistant is really storing its responses from the first question and then being able to answer the next question. And that's how it creates context over time. So the user role is the final role, and the LLM interaction represents the human element, which provides inputs to the model, which it can actually respond to. These inputs can be textual or advancements in models such as GPT-4 Vision, visual in their input structure, allowing for more versatile exchange of information. And here's just an example of how you can do multiple inputs. So you have a text input. So you set the role, and then for the content, inside the content variable, you can set the multiple inputs. So you can do text, so what is in this image? And then you can say, you can put in the image URL. So there's two options that you can use for this action, for two variables that you can use pre-built for OpenAI, is image URL and text. And you can also, instead of doing URLs, you can do actual images that you have as well. And you just have to convert them to base 64. Just a side note, OpenAI's Assistant API is also a really powerful tool that enables developers to really build sophisticated AI-powered applications. It's designed to really harness the abilities and capabilities of GPT models and provide a framework in which these models can operate as assistants directly. So it responds to user queries with context-aware answers. An assistant created via this API can really follow specific instructions and actually serve as kind of like your assistant, but directly. You don't have to use the code completions, and the Assistance API is really great because it includes code interpreter and the retrieval tool, which can really fetch information and make the assistant really useful for your specific use case. And I did a SingleStore presentation a week ago about this, called Using OpenAI Assistants for Voice-Activated Financial Advisors. And this session really demonstrates how the API can be used in financial context, and you guys can check that out on the SingleStore website. Another side note is GPT-4 Vision is really cutting edge model from OpenAI that it really excels in interpreting and responding to visual data. One of its core strengths is answering questions about contents of images. And for a more in-depth look, again, consider revisiting my SingleStore presentation, how to chat with image data using the new OpenAI GPT Vision API, and I go over a pretty cool demo of how that's working. But that's another really cool model you can be using for your LLM apps. So now the next step is really once we set up the API, once we know which model we're using, once we know like what the user, system, assistant roles are all doing in your application, it's time to actually consider customizing your GPT LLM, which can be achieved in two primary methods. The first one is fine-tuning, and the second one is RAG, which stands for retrieval augmentation or augmented generation. And fine-tuning really adapts the model to your specific data, enhancing its responses to your specific use case. And RAG combines retrieval of your relevant information with the model's actual responses, and it creates a contextually aware outputs that you can use. So just a brief differences between the two. So fine-tuning is really a crucial process in AI development that allows you to really take a pre-trained language model, and such as GPT 3.5, and take that model and train it further based on more vast and more specific data, because GPT 3.5, GPT-4 are trained on vast, diverse corpuses of data, and it makes it really a good like ground to really set up for broad understanding of language structures and patterns, etc. But once the model has this foundational language, it can be fine-tuned for specific and smaller specialized data sets. So for your specific app that you're building, for your specific company, if you have user data, if you have interaction data that you want the LLM to understand, this is where you do it through fine-tuning process. And this data set is really carefully curated to align with the nuances of particular application, whether it's generating text for creative storytelling, and or interpreting legal documents, etc. There's so many use cases where fine-tuning was really important, where you can actually feed in your own data and create the model specifically with the pre-trained model specifically targeted towards your domain. The fine-tuning process leverages the model's existing knowledge base and combines it with the domain-specific knowledge that you're going to be producing. And this, for instance, this really with the fine-tuning for a medical text generation, the model really becomes adept for medical terminology, and etc. And there's so many different use cases where you can feed in like a file of your data and train the model specifically for that. And currently, fine-tuning capabilities with OpenAI, such as models such as GPT 3.5 is completely doable. And there are many applications with SingleStore that allow you to do that as well, in a really, really great way. But however, the access to fine-tuning with GPT-4 models really requires special access from OpenAI, and actually GPT-4 Vision for fine-tuning vision models is actually not available at this time. So the code snippet on the slide really shows how to initiate a simple fine-tuning process using the OpenAI Python client. And it illustrates the process of uploading the training data and starting with the fine-tuning process. And this customization step is really instrumental in optimizing the LLM's performance. And you would take in the JSON file and it would train the file. And it's only a couple lines of code just to create your fine-tuned model that's really adept at your specific data that you're providing it. So next one is a little bit more advanced of a technique that called retrieval augmented generation. And this synergizes the strengths of the large pre-trained language models such as GPT-4 with really an external search for retrieval mechanisms. So the purpose of RAG is to supplement the generative power of these models by enabling them to have access to really utilize a broader range of information from the initial training. So the process begins with the retrieval step. And when presented with a question or prompt, the RAG model first retrieves relevant documents from a large corpus. And the way it does this is it's using the context of the user's prompt to find the most relevant documents. What you're going to do is provide a lot of documents for it to analyze. And what it's going to do is going to go through those documents through a retrieval mechanism, based a lot of times through like dense vector representations of the documents, and then complete a query. And this is where it really matters how fast your queries are and really how real time your queries are. And that's where SingleStore comes in. SingleStore is a really, really great tool for RAG because of its ability to go through these queries really fast. And through a completely on something on the cloud. And that's such a great thing for something where you're doing RAG and trying to create these really customized responses. The second step is generative step. So once the relevant passages and text from your vector database or your vector embeddings vector representation has been retrieved, what you would do is you would feed that into the generated model along with the original queue. So for example, here's an example of this use case, right? So you have a user who is querying about a medical disease that they have, right? And the model does not have much details about obviously it has the internet, it's trained on the internet, etc. We know what ChatGPT is trained on, but it doesn't have too integrate details into these. So what you do is you have the RAG have access to medical papers, a lot of medical documents. This is an example. You don't have to do it with medicine. You can do it with any industry where you can really fine tune it, or you can really make it more precise based on giving it data. It'll search through that using its vector representations, and the query step is really important. But then what it'll do is it'll find the relevant information, take that, and then put it back into the generated model, such as GPT-4, combine that with the original query, and then the model generates a response leveraging both its pre-trained knowledge and information from the retrieved passages. And then the entire system, including the generation components, can be fine-tuned from an end-to-end downstream task. And this means the model can really learn over time to improve its retrieval choices based on the quality of generated responses that it gives. And that's a little bit more complicated, but pairing the SingleStore with RAG and AI applications really creates a formidable duo for real-time data processing. and response generation. SingleStore's database really is an architecture that ensures RAG models have really rapid and efficient access to substantial amounts of data in a really fast manner, and a really critical component for generating timely and relevant responses. The big thing about RAG right now is the query step. It takes a long time to find, if you have a lot of data, right, that you're providing the RAG for context, it needs to find the correct information. And SingleStore stands out for its high-speed retrieval capabilities, which is really essential when the RAG model requires immediate access to the latest data for generating responses. The seamless integration is really essentially beneficial in scenarios where the AI must really understand and reply to queries where it needs to process live data streams, or for instant insights, the user needs it. Furthermore, SingleStore facilitates advanced search functionalities like vector semantic search and keyword matching, which are really integral to the RAG's retrieval step. And this capability really ensures that the search is not only based on keyword frequency, but also in the contextual meaning of the query itself. So it leads to a lot more accurate and relevant data retrieval. And the ability to integrate with ETL, extract, transform, load pipelines, which really efficient processing of data, and really ensures that the RAG model has the most updated and cleansed data available. And additionally, SingleStore's compatibility with major cloud providers like AWS, Azure, GCP means that it can leverage cloud capabilities and its scalability for robustness and really further enhancing the RAG's model performance. Here's just a code walkthrough of how this is going to work. So this is just a demo that I created. We'll be providing the GitHub as well of how you can leverage SingleStore, LangChain, and OpenAI. So you'd import all of these from LangChain, and what you're going to do is, first of all, you're going to load the data into a text loader. And you can there are many different ways you can load the data. It can just be a plain TXT file. You can use services such as Unstructured or on any other platforms that really take unstructured data and makes it into a really structured format that LLMs are really efficient at responding to in these embedding formats. And what you're going to do is you're going to split the text in these chunks, and you're going to use those texts and set up the embeddings. And what you can do is with the doc search here, you're going to do SingleStore db.from documents text embeddings. So you're setting the text that you set up with the splits, the embeddings, and the table name inside of SingleStore. SingleStore db will allow you to retrieve that really fast. So then you would just do what we've already discussed. You'd set up your prompt. You'd set up your prompt as well, your prompt and your input variables here. So what I'm doing for the prompt is actually saying, use the following context to answer the question, with the context and the question as well included in that prompt. And it'd take that prompt, it'd use LangChain to access the OpenAI model, and it would feed in the prompt, and it would get the retrieval with the question and answer API from LangChain, which is retrieval QA. And what it would do is use a specific model. So we're doing model with GPT 40613, which is Turbo, I'm pretty sure. And we have the LangChain retrieval, which is DocuSearch as retrieval, and which is actually getting it directly from SingleStore. And yeah, this is really an example of how you can use LangChain, SingleStore, and OpenAI to kind of create a customized model. And you can feed in any TXT file that you want. It can be your customer data, it can be medical information, any specific data that would be really useful for retrieval in the process of actually using your data would be really useful in creating these outputs for the users. And the final step is really the deployment and scaling. So you want to make sure you're using cloud-based solutions or some dedicated hardware for optimized AI workloads. You want to make sure that your model management is really good and your optimization is great. So you want to employ techniques like model quantization. We won't get into that today, but reduce computational requirements, reduce API costs, facilitating easier scaling. And finally, you want to really do continuous fine-tuning of your model. Whether you're doing fine-tuning, whether you're doing RAG, you want to make sure that your data set is really great. And that's really easy using SingleStore's applications directly into your application or LLM applications. So, really the future, just looking forward of LLM applications. So This week, Google released their GPT-4 competitor called Google Gemini, as we mentioned a couple of times through this presentation. And Gemini is really built from the ground up for multimodality, and really has reasoning seamlessly across text, images, video, audio. You saw the video of them talking about a duck. They're drawing a duck. They pull up the blue duck or whatever. That was a really cool video, and it really shows the direction that large language models are going in and where LLM apps are going in as well. It really shows that most LLMs will now include a heavy aspect of multimodality, pushing towards more AGI, allowing you to communicate directly with computers with your voice, with images, and integration with emerging technologies. So LLMs will really be expected to seamlessly integrate into technologies like AR, VR, IoT, offering a more immersive and interactive experiences. And there's this technology released a couple of months ago now, or a month ago around, and it's called Humane, and it's a Humane AI pin. Essentially, you see on this bottom of my screen, there's this pin on his hoodie, and it allows him to look directly on his hand and see insights. You can talk directly to it. It's all powered by OpenAI. And these large language models are kind of taking over hardware and these emerging technologies as well. And yeah, that's pretty much it. And we can the code walkthrough we can do, or we can have some questions that Matt brings up. But yeah.
Awesome. Well done, Ayush. So we can get into the Q&A section of the show now. We only have like 2 or 3 minutes. But if you want to participate, just hit that Q&A button at the bottom. One question that came in, Ayush, is when you fine-tune your LLM, are the parameters and data updated in the model with your customized data? And how can you ensure privacy of data when you're training an LLM?
Yeah. So when you're okay, so can you say the first question again, and I'll answer them one by
Yeah, the
one.
first part of it was when you're fine-tuning your LLM, are the parameters and data updated in the model with your customized data?
Yeah, so when you're fine-tuning the LLM, so there's two things. When you're fine-tuning it, you're actually putting the parameters directly into a JSON file or TXT file or whatever, and the parameters are fed directly into the model, and you're going to get a new model architecture that you can use directly that have the all of your embeddings and everything directly involved into that. And RG is more of a process where it takes the output of the pre-trained model and it combines it with retrieval mechanism where it's actually going out and getting it. And to ensure user privacy, it's really important to actually make sure that you are, like taking into account which data that you're putting into these models for retrieval, for fine tuning. You don't want to put in a specific like phone numbers or like addresses, something like that. It's really important to make sure, like for user privacy, that the model does not actually generalize for different cases where it's actually giving out user privacy data. There's actually cases with OpenAI where it actually leaked some user data, which is really bad. And there's a lot of things that are going on right now with AI security to make sure that models are not trained on specific user data. And as I think, for example, like if you ask ChatGPT about any like personal questions about like a specific person, it won't be able to answer it. And it's really about like your fine-tuning data. If you want to provide clean data, you don't want to give like customer data or something that's very sensitive to fine-tune it. So
Good stuff. I think we have time for one more question before we do the AirPods winner announcement. And rest assured, we'll follow up with everyone via email. Sorry, we don't have a ton of time, but there was some questions about the limitations on size. There was questions about pricing. And I know in past webinars, Akmal has always said he's just shocked at how cheap, all of these options are, OpenAI and others. And then this question specifically is saying, what if I have a size 500 gigabytes of docs and PDFs and PPTs and Excel sheets, and I want to apply RAG to that? I know SingleStore is a great option for this kind of thing, but I wonder if you could talk about that really quick.
yeah, so that's a great question. And I'm not sure about the current size limit of OpenAI's models. It's definitely specified on their website what it can actually take in, but you can put in a lot of data for RAG, especially because RAG is really about not the amount of data, but it's the time it takes to retrieve the data for your actual response. So the retrieval process, most of the times the data is put into vector form, So it's there's vector representations of the data itself. So all your docs, your 500 gigabytes of all your information is going to be put directly into a vector database. Something like SingleStore would be really great for that, for really fast retrieval on the cloud. So that's a great option. And I'm not sure about the specific size that OpenAI allows for, but I'm sure that 500 gigabytes is something really doable for SingleStore for actual really fast retrieval, especially in the vector representations that we're seeing today.
Awesome. Thanks, Ayush. Okay, on to the AirPods winner. And reminder also, tomorrow we're going to be doing Google Gemini preview and hands-on with Vertex AI. I put the link in the chat. Hopefully, I'll see you at tomorrow's webinar. So RSVP there. The announcement you've been waiting for, today's AirPods winner goes to Bradley Volker, Manager of Business Intelligence at Harley-Davidson. Congrats, Bradley. Thanks for joining. If that's not you, don't give up. We're going to announce one more AirPods winner by the end of the day for anyone who has tried out Ayush's GitHub. So I put that GitHub into the chat earlier, and I'm going to put it in there one more time. And we're also going to email all of this stuff out. So recording will go out, GitHub will go out, relevant resources you will get in your email. Thanks again, everyone. Thanks, Ayush, for an awesome presentation, and we look forward to seeing you again someday soon. Bye,
Awesome.
everyone.
Thank you, guys.